to make sure that it is shared properly. Yes, great. Cloud application resiliency. And, kind of a lot of people ask, what is cloud application resiliency? Why not, backup and DR and so on. So let's get into the kind of a definition of why cloud application resiliency itself. And that underpins the reason for this particular webinar. As you might have seen from the webinar description and so on, the cloud outages are real, and those outages affect real applications. And even though they affect a portion of the cloud infrastructure, they do affect some of the critical applications as well. On the other hand, if you think about overall the cloud platforms themselves, they are the enablers to move to the next level of application resiliency. Now, if you consider things like the data centers and resilient data centers and backup and recovery with multiple storage systems, multiple backup products, multiple configuration management on top of the recovery, and having to really kind of test all of these over a period of time to make sure that you can actually bring the applications back is really hard work. Has always been a biggest problem. In fact, some situations it's actually a project if you signed up with some of the resiliency providers. So the cloud platforms have really enabled the modern application level resiliency. In fact, if you move towards containers, the resiliency aspect of it, in fact, improves much better, at least for the components that run in the cloud native platforms like Kubernetes on top of resilient infrastructure provided by the cloud platforms themselves. On the other hand, if you are enabling some of the existing applications, either by lifting and shifting over to the cloud platforms, or you are, after the lift and shift, you are modernizing them by using the existing services within the cloud platforms themselves, you also have a better resiliency compared to the previous data center world. So in a sense, cloud has enabled us to move towards application level resiliency that wasn't possible before. Given that there are types of applications, and those type of applications can only tolerate a level of disruptions depending on the type. If you think about 99% availability requirement, it could be used for batch processing, data extraction, transfer, and so on. And if you look at 5.9 type of applications, you're looking at ATM transaction, telecommunication systems, and other applications are in between. And in every one of these type of applications, you can see the maximum disruption that these applications can tolerate, or the businesses can tolerate. And given that type of application, and you could position your application in one of these categories. If that's the case, what is the possibility? What is the aspect that services like Appranix or third-party services could bring on top of the cloud application platforms to reduce the disruptions? At the end of the day, if you're looking at the requirement SLA requirement perspective, if you're looking at 99.99% or even 99.95%, the maximum disruption per month is about 20 minutes. I mean, this is like, even if you did an update to one of the components of your application, the potential for that application to coming down could be real, and that could be more than 20 minutes. So if you're operating at 99%, and if you are thinking of going towards 3 nines, then it is almost like 300% improvement, which means that if you translate it to the real work, could be the number of people that you're putting in terms of making sure that the procedures are correct and everyone is operating like seamlessly and so on. And also the platforms behind the infrastructure has to really cooperate, or you will have to make sure that infrastructure actually behaves the way that you like. So we look into all of this aspects as well as the potential solutions here with respect to bringing the resiliency. So, as I mentioned, the disruptions could happen in multiple ways, and I have listed out a few of them here. And by the way, we have also generously borrowed some of these data points directly from the AWS well-architected framework. So you could go and check out. There are multiple pillars within the well-architected framework. We are talking about the resilience pillar part, right? The availability part, and there are other pillars with respect to security, with respect to operations, with respect to cost, and so on. We are here talking about well-architected framework only for the resiliency aspect of it. So, given that, a single bad deployment or configuration change could affect the entire application potentially, right? Or individual service failures within the cloud platform within a zone or even within a region could affect your applications. Could be even because of a maintenance disruption, right? But your application is supposed to work because it's a third-party data center. It's a cloud provider, but they are still a data center provider. In those cases, you will have to really think about how to guard against those individual service failures as well. Now, another type of completely different type of service disruption. Now, if you signed up for any of the ransomware RSS feed, ransomware attacks, it keeps happening every day. At least in the news, there is something or the other coming up. Just yesterday, I noticed that one of the southern hospitals, I don't want to name the name here, Southern Hospital completely closed their operations because they couldn't run the hospital due to a ransomware attack, and they have been struggling for the last 3 days, right? And they cannot bring back the systems. Just imagine the situation with emergencies, a situation with patients that are critically ill and so on. Ransomware attacks are real, right? In those situations, if you think about what type of disruption that's happening for your business services, the way you have to handle it has to be completely different. At least you have to rely on the aspect of the resiliency coming from the infrastructure, which is great with respect to cloud providers, but on the other hand, applications have to be taken care. Last but not the least, even though the cloud region failures are rare, they do occur. And that's why the well-architecture framework from AWS and other providers clearly outline the reasons why you have to really take care of the resiliency from an application point of view, right? The way you consume the services, keeping in mind that those services have their own, availability SLAs. And you'll have to also read the fine print with respect to those availability SLAs as well. So if you are responsible, if you are a site reliability engineer, a guy who is responsible for really making sure that application SLAs are really taken care of, you can actually promise something with this, to the businesses from an SLA perspective, or internally you track those SLAs and translate them into SLOs, service level objective, and then chop them off into some measurable items called SLIs, the indicators that could be pulled together to create the SLO. So the title is not a miracle worker. The title is site reliability engineer. And if you're a site reliability engineer, the problems of disruptions are real. Then you will have to be prepared with some level of capability to take care. And there are other categories of cloud application disruptions. I don't want to go through every one of them. You could as well go and refer to the well-architected framework. Some of them are kind of credential expiration sometimes you take it for granted, but that could cause a disruption as well. Dependency failures with respect to a dependent service failure that could cause the entire business service to come down. So all of these are real. If that's the case, what is the cloud provider responsibility? The cloud provider, takes care of the infrastructure and service availability, service security. And again, service security and availability are different parameters for different services. They will have 99.99 availability, 99.9 availability, and then even within that EC2 availability, you will have some restriction with respect to a single VM is available for 99.9, and then if you are using multiple EC2s and other services along with EC2, then that 99.99 doesn't apply. So those are like fine prints that you will have to really take care of. And if you're managing that infrastructure through the API or through the console, they have different types of availability SLAs. They are 99.9 most of the time, right? These are control plane SLAs as opposed to the real infrastructure level SLAs. And again, clearly defined, some of the AWS well-architected framework documentation spans, 60 pages. And a specific one, if you think about financial type of applications, there are about 70+ pages of well-architected framework. All the descriptions, all the necessary design considerations, and so on. So if you do not have access to any of that, please let me know. We will send you the copy of those documents as well. From a customer responsibility perspective, right, you are responsible for the application configurations, application design aspect on top of the public cloud platform. Application availability from the point of view of backups and recovery and resiliency, and application level security. So clearly defined shared responsibility model that has been existing for a while. And if not, I'm just putting that out there just to make sure that you kind of internalize those aspects as well. From an operational best practice perspective, right, these are the higher level, and every one of these bullet points, you could go 10 levels deep, right, in terms of how you could really adapt those changes. So you could put in autoscaler if you see an aspect of the demand, a particular component of the aspect of the demand within your application. And you can also leverage multiple levels of monitoring. I mean, the infrastructure level monitoring or application level monitoring. So you'll have to leverage, monitoring overall. I'm sure you guys are doing that. No questions about it. Just make sure that there is a critical aspect of how you monitor. It's not about throwing the dashboards and looking at the NOC and stuff like that. With respect to a particular application, how do you guarantee the SLOs with monitoring? Now, with respect to deployment as well as changes after the initial deployment, one of the best practices that is well understood now, if not, it's getting more traction, is infrastructure as a code-based deployment model, right? You define the infrastructure as code. Hey, this is what I want, and you could let AWS to take care of running that template or the stack completely. If you could code it up, and then make sure that if the infrastructure cannot be created for whatever reason, you could transactionally roll back that entire stack itself. So all those facilities, in terms of providing the right deployment and consistent approach to deployment, is well understood now. So it is better to practice those aspects. Back up your data. So this is like a very higher level definition. Backing up of what data? And that data involves, okay, is it like my data center days where I go up and back up the virtual machines? Or what about the volumes? What about the data disks that are attached to my file system and that runs let's say Elasticsearch or any of the databases and so on? Am I supposed to back up those? Obviously. And am I supposed to back up the cloud configurations? If the cloud configuration is lost because cloud formation templates are stored, let's say, in one of the GitHub, and you have a different version that's very abstract. You don't know the configuration that is actually created in the infrastructure, and there is a disconnect between the actual template and the infrastructure that is already running. The configuration changes might occur through some other means, not necessarily through cloud formation alone. And am I supposed to back up those configurations? Am I supposed to back up load balancer configuration, or even the security groups? People lose security. Believe it or not, people lose security groups. VPC configurations, right? All of that, if you are really keeping track of those configurations, that's great. Now you'll have to marry them with the actual backup of the data, right? If you're backing up through EBS snapshots and so on, now you have to really think about all of that coming together to give you resiliency from an application environment perspective. Now, once you have all of that, that's great. Now you have to test the resiliency as well. So how do you really test this? You cannot go and fire off something in your production VPC. It's going to have all kinds of conflicts, even the IP conflicts or other resource conflicts, and you may run into quota problems, right? So how do you really test within that particular resiliency, particular VPC for resiliency? And then if a true disaster occurs, as you had seen before, disruptions do happen in multiple forms, then how do you really recover this, right? All the configurations, all of that together. Luckily, AWS Infrastructure Resiliency is great, right? Within a region, sometimes you see 3 different availability zones, roughly about 30 miles distance. That's good enough for a lot of the cases. And in cases where, if you're not satisfied, you can pretty much take from one region to another region. That's another great facility that is available because of the cloud platforms. And that's just not, possible before unless you spent enormous amount of money and time, et cetera, et cetera. So now that level of infrastructure resiliency is perfect. That's available. And, when you think about, leveraging these aspects, you're not alone. If you're considering, resiliency beyond just one particular zone. Typically, when you start off, you would land, let's say if you lifted and shifted, you would typically land in a particular zone in a region of the cloud, and then you try to use all other aspects, and you put your production environment. That itself is it's a lot of work. And now you'll have to really think about, so should I have auto scaling going between 2 different zones, and how do I really change that? And you could improve that aspect, or you could really think about, so how do I really take care of all of this, and then shift it over to another region. Backup companies would say, yep, you back up and back up the virtual machines, back up the infrastructure with respect to EBS volumes and so on. The issue is not that. The issue is that resilience of the application, which means that you will have to consider all other configurations as well. So we have been educating companies. We have been educating with respect to application resilience. Recently, we had a webinar through CloudBees, which is a DevOps vendor. Some of you might be using Jenkins as one of the DevOps tools. And we also did another huge blog with Red Hat. And all of this, in fact, the Red Hat webinar has, the blog post has attracted close to 4,000 now. This is a bit old data. And there is a need for cloud resiliency, and Gartner has been pitching this. You have to take care of your application resiliency. So if you're doing that, one of the aspects of resiliency is you will have to do DR test. We are using the DR aspect of it as opposed to the resiliency aspect because it's a known quantity with respect to I have to do a DR test. So which means that you will have to think about your application readiness, application environment configurations, dependencies, network checks, storage checks, right? Do I have all the snapshots with respect to my environment and so on? Cross-region replication, if you have different encryptions between your primary region and the second region and so on. And security logging, they are all taken for granted, but you will have to really make sure that they are all coming with you. So you could architect kind of a simple blueprint. You could architect your application appropriately within a region and then switch that over to another region if your application really allows. Otherwise, you will have to look at, is there an easier way to do this, right? And a lot of people really ask, so, backing up is not the problem for us. We have a mechanism to back up on AWS. But at the end of the day, it is the environment that really kind of complex, right? How do I bring that environment? And that's where we come in. Appranix is a site reliability automation service, and it delivers true cloud application resiliency for applications that are running on the cloud platforms, right? We have been rated as one of the EMA top 3 platforms. You can go ahead and download the report when you get time to read. And we are a secure enterprise SaaS service. It has been operating at 99.9% SLA with 24/7 support. When we say 99.9% SLA, we have to internally manage at 99.95. To that extent, we are an account within our own service, right? So we eat the dog food first before letting other customers to use our system. And as an example, one of our largest customer is managing 8.8 petabyte with 1,400 resources, 25,000 snapshots across 8 different VPCs. So you could read at the top, the level of complexity that we are handling for one of the topmost, Fortune, I would say 50 type of customer. Another one is an EdTech company. This company runs their SaaS platform on top of Google, and we provide the same resiliency with other capabilities that they can update their application really, really quick. SLO Luxottica is another great customer of ours, and as you can see, is a Fortune 1000 customer, and they pretty much went with us for entire digital transformation effort, and particularly for the resiliency aspect of our application. So now, this is all fine and dandy, but when you think about your application, your application most likely be utilizing, if not all, are pretty much, most of these services from AWS. So pretty much the standard infrastructure services. And if you're using Kubernetes or container-based microservices, we'll cover that aspect as well. So I have mixed with respect to our demo. You'll have the combination of that. And your application runs in multiple cloud environments. It could be made up of, individual components running in separate EC2 instances, and then services connected to each other. Now, in order to decrease the cloud disruption, increase your SLOs, right? The level of effort that you'll have to do is to make custom automation. If you have some infrastructure as code that is deploying your current environment, that's great. Continue to do that, please, and also make sure that you consistently do that. Enhance that with the custom automation. On top of that, you will have to manage the snapshot lifecycle. So if you're doing the snapshot lifecycle management or some kind of data lifecycle management, you will have to now think about the combination of that lifecycle of the snapshots with your automation, and then infrastructure as code versioning and state management, and the cloud service configurations that you have to track after the deployment, after the changes occur, because configurations could change anytime, because the entry point for those configurations are many nowadays, as opposed to previously, a kind of a tool would do the configuration changes. Now, an API change could come in, or a DevOps tool could be updating on the side, and you could be using your own existing data center configuration management tools on top of the cloud platform themselves. So there are multiple ways a configuration could be changed on an environment. So you'll have to keep track of all of that. Now the question is, can you really guarantee that application reliability, right? You'll have to think about, with all the changes that are occurring, even if you made all of that, what's your SLO? And then turn back and think about, there is an automation system nightmare here, right? You will have to marry all of that and then provide some kind of an SLO, a single statement that makes up, okay, so I can do 99%. I mean, what guarantee is that? Can you provide that guarantee today? 99.9. And now you have to think about, so what is the amount of disruption that that a particular business application can actually handle, right? And with all of that, now you'll have to think about, can I increase that, right? Can I improve my SLO over a period of time? Not necessarily tomorrow, but over a period of time, right? You could. I mean, the idea of Appranix providing the service is that you could actually get started really, really quickly as well. So what you have to do is to go to Google and type AWS and Appranix, you will get to the marketplace, and you could simply subscribe and immediately create an account and go forward with that. You don't have to have any infrastructure to worry about, none of the complexities that used to be in the data center, or even some of the cloud platform tools that provide other aspects of resiliency. You don't have to go through any of that. You subscribe and move forward, add the policies that you want with respect to level of protection for your entire application environment. Could be an hour, or you could even reduce that, or you could actually add a combination of the protection policies, hourly policy, daily policy, weekly policy, monthly and yearly as well. That way you could go back in time. And what Appranix does is it creates an application environment time machine automatically based on those policies, and keep adjusting those time machine based on the policy description that you provided, right? So in essence, with 2 clicks, pretty much, you could create a time machine that keeps up with you, with your configuration changes, and go ahead and make the change, knowing the fact that you could always go back and roll back and revert back, right? All of that capabilities are now possible. And you don't have to worry about infrastructure as code. You don't have to worry about managing all the complexities of data lifecycle management and so on. So under the hood, if you think you have the infrastructure with respect to this level of complexity, I mean, some of them, you can take away the Kubernetes aspect of it. Still, you will have a bunch of services running in the backend, and think about creating an application environment time machine with a click of a button. Then the environment continuously gets updated. It's kept up to date with your changes, and you can go back and click to recover and roll back your environments. So with that, you can also do is that most of the modern enterprises are moving towards DevOps model, right? A consistent way to deploy and a faster way to deploy the applications as well. If that's the case, do not worry about any complexities with respect to resiliency. If you're an SRE, you'll be worried about this all the time. Some of the even very sophisticated cloud operators, right? They struggle with this notion of resiliency because there are so many moving parts, and those moving parts move really fast as well. So if that's the case, you should keep up with those changes. So you can let Appranix know with one single addition of code, pretty much you can add the resiliency. That single line of code creates a time machine for your environment, right? With that, what you could do, you could use it for multiple use cases. You could use it for recovery purposes. You could for multiple rollback purposes, or even deploying your environment across a different region altogether and keep in sync for multi-country deployments as well. So multiple uses, but we talk about resiliency and resiliency alone. So given that, what we'll do is that we will quickly jump on to the demo itself. I'm looking at the clock here. So assuming that you typed in here AWS and Appranix, you would go to, I will be directed to the marketplace, and from the marketplace, you can simply subscribe. I subscribe to our demo, so we are ready to go here. So here, once you log in, the cloud environment is ready to go. So we are not going to recreate that cloud environment. Here, all you have to do is to discover that environment. So for discovery, configuring the cloud, put a cloud name, and give the access keys and secret keys. You could actually create a separate one, nothing to do with your production environment. You can create a separate one to allow Appranix to read your metadata. We do not copy any actual data, simply read the metadata of your configurations. And they are all secure in terms of in-transit encryption as well as at rest encryption as well. 128 SHA-based keys with 1028 key spaces. So pretty well secure. And as soon as you give that information, Appranix automatically discovers all the infrastructure necessary for your application environment. We list out only the virtual machines here. You'll see what type of cloud resources automatically get discovered by Appranix here. Now, we created what we call as an assembly. An assembly is a composition of resources. All you have to do is to click a few of these and create an assembly quickly, or you can add to an existing assembly. That's all you have to do with respect to kind of assembling, roughly representing your application environment. This allows you to kind of chop off some of the critical applications separately from less critical applications, tier 1, tier 2, and so on. And that way, you could put different policies for those environments as well. Now, once you create that assembly, pretty much the environment Appranix automatically creates all of this for a particular assembly. It assembles the resources only for that particular assembly. None of the other resources will show up. So you can see the compute, customer gateways, EBS volumes, of course, elastic IPs, internet gateways, all of that will be automatically discovered and assembled for that particular application. In this particular case, we are running a distributed application on top of Kubernetes, just to give you an idea of the complexity that we can handle. And then what you have to do is to go and put a policy. So you could, we already have an hourly policy. You could say hourly, daily, weekly, and so on. So daily policy, you can start at 12 a.m., for example, change depending on the type, and weekly policies as well. You can also do snapshot retention. So how many copies that you want to retain. With respect to just snapshot, everything else is automatically copied and maintained, but snapshots are the physical thing that you will have to really copy over, because it's data, it takes time. So depending on the number of snapshots that you want to keep, just put that the numbers here, and Appranix will automatically take care of it. So given that, the time machine gets built automatically for you, right? So this is a time machine. You can go back in time, and depending on the policy, the life cycle is automatically handled. All the snapshots are deleted. All the configurations are automatically deleted. For every one of the copy, we copy the configurations and keep in sync with your application environment. So if go ahead and confidently make those changes, right? Appranix will keep track of all those changes, make a copy so that you can recover from any of those failures. Right? Just imagine from the snapshots of the entire application environment, you could pretty much recreate that environment, not only in the local region, but also in another region of the cloud, east to west. In this particular case, the primary region is running on the East Coast. The type of application that is running here is this, right? So it is, let's put it back, come on. Right. So this application is a complex application, and it runs on Kubernetes, multiple pods. And if, by the way, if you're not familiar with Kubernetes, not to worry, it is just, the containers are orchestrated using well-known orchestration engine called Kubernetes. And though, the concepts within Kubernetes vary, but in the end, these are a bunch of applications that are running there. And the application that is running for this particular demo is an e-commerce application where you could go and buy torn socks, right? Why don't we love it? Right? It's like, if you think about it, people are, this is, by the way, it's a real world application. It's a real world application running in the UK. It's an e-commerce site. You can buy $99, torn socks. If you're really kind of would, fall in love with that kind of a, statement making thing, you could do that. But in this particular case, what I have done is that I have bought, a few of the socks here, right? I could go on and proceed with the checkout. I have a login here, Govind Rangasamy. So what I'm going to do, I'm going to intentionally disrupt this particular environment. So what I'm going to do, we are running in Northern Virginia, right? And let's take that and oops, sometimes I have to refresh it just to make sure that we get the latest here. So all of them are running. So what we are going to do, stop those instances. Now, the application will obviously get disrupted, right? So this is gone. This application is also down. And a real disruption. This is a panic mode. So if somebody did something, some attack happened, who knows what really happened. Now, in a panic situation, now we have to look at options to recover the entire environment somehow, and at least buy time to recover the environment. So as you can see, what we are going to do, we are going to recover the entire environment in Oregon. As you can see, there are no instances here. And also here, I'm showing the Oregon region VPC. There are no VPC configurations as well. It's an old ones, the pre-created ones. So we'll create more. We do not, even if you are running existing VPCs, do not worry. VPC configurations, we'll not disturb them. We'll create completely new ones for you. And all the subnets, route tables, internet gateways, all of that, network circles, all of that will be created with respect to your primary environment. So these some existing ones, we will not touch them. Now what we are going to do, we are going to go to Appranix here, and at Tolok, let's go back and recover at 1, because that's when disruption might have happened. So we have a copy of that environment. We are going to recover in recovery region. Recovery region is currently configured to point to Oregon. So we are going to recover in Oregon. As you can see, since you had already kind of set up this environment ready to go with a few clicks, all you have to press a button is to recover that, click that recovery button. So once you click, allow Appranix to take care of the rest, Appranix will automatically create those instances for you and take care of the rest of the environment creation as well. So you can see this environment will be created using the cloud formation. So another interesting fact here is that Appranix automatically writes a cloud formation for you. Based on the configuration of the infrastructure, multiple nested stacks will be created automatically for that particular environment and for that particular environment copy, right? So here, the stack that's already in progress is the environment that is getting created. You can see the number of resources, it will keep increasing here. So the number of resources, even though the number of instances are about 10, the number of resources will be about 54 of them. So you can see the entire environment, even though Kubernetes is complex enough, it gets literally recreated, right? And the load balancers will be recreated as well, which means that we should have a copy of the configuration for the load balancer to orchestrate on this side of the country, on Oregon, on the Oregon zone, within a particular zone of Oregon region. Now, all the snapshots, volumes, everything will be automatically set up for you. Do not have to worry about which version of the snapshots. If it is the environment that I pointed to, the large enterprise, 25,000 snapshots across like 8 different VPCs, multiple accounts. Now, if you have to deal with one of those, how many SREs, how many operations people that you have to deal with, right? And even if you had, again, the same problems of management, problems of creating this entire environment becomes really, really complex. So I can see the cloud formation is working feverishly. Again, 58 different resources have been created. You can see the environment is successful. So pretty much within about less than 5 minutes, the entire cloud formation has recreated the environment here. So let's see how that environment actually looks like. So what we are going to do, we are going to actually switch the DNS as well. So it's pointing to the east. The application is not going to run. So what we are going to do is to switch the DNS as well. So let's update the DNS. Of course, every update is it's very sensitive, let me say the least. So you'll have to make sure that you type in capital letters, update the DNS so that you know what you're doing, and the DNS will be updated and will point to the west side of the application infrastructure here. All the VPCs, all the subnets, all of that will be recreated here. All of that gets recreated. You can see the KTS VPC was created. Route tables, gateways, if there are gateways, elastic IPs will be recreated. We are just pointing to the same elastic IP anyways. Network circle, I don't think there are many, and so on. So all the security groups, by the way, you'll have to bring all those security groups so that the components of the platforms continue to talk to each other the same way the production environment used to have that information, right? So all of that is great. Now let's look at the instances that are running here. So the instances are running, they are initializing, so it'll take a little bit of time to initialize. Because even though you start the instances will take a little bit of time to kind of get ready with all the init scripts and so on, so that your load balances could catch up. So the load balances already are created, right? And the load balances are waiting for the health check for the instances to be complete so that they can hook up that entry point with the load balancer here. And while this is happening, at least 3 instances got back. So Kubernetes itself, the masters are running. So there are like 3 masters and 6 other minions are running for Kubernetes platform in the backend. And as soon as the instances are ready to go, the load balancers will kick in. So all the instances are ready. The load balancer will take a little bit of time to catch up. So the HA app is ready. So the application should be up and running. Application is back, and the application, let's say a little bit of time here for the application maps to catch up. The application itself is ready to go. So should be running as well. Give it a little bit of time, but you can see the application has come back here. It is pointing to the same DNS entry point, but the mapping is basically pointing to the US West, right? So in essence, what you could see is that the entire environment, application environment, consisting of your EC2 instances, your volumes are brought back, right? All the volumes are here, are recreated, attached appropriately, and in the order in which they were created as well, right? Elastic IPs, elastic IP, as I mentioned, this we are pretty much reusing the elastic IP from the other region anyway. We don't have to recreate them. There is nothing to recreate here. And the load balancer configurations and so on. So all of that are completely recreated in the other region, right? So that the application actually runs. So the application comes back and we log in again here, and you can see that the cart is intact. $98. I had a bunch of socks bought. This all great. Now, overall, within a webinar time frame, less than 20 minutes, so to speak, we are able to bring back the entire environment, application environment that is complex enough. If you are running, this SockSop e-commerce site, just imagine the disruption that could cost you. Enormous, depending on the situation, depending on the type of application you're running, right? So at least now you could do the test. So let's say you completed the test. Now you don't want to have any of this kind of eating your, you're worried about the cost, let's say. You did the testing, you're satisfied, let's go ahead and reset the entire environment, right? So you can reset. Of course, we ask you to reset, type in capital letters, because you might be running your recovered environment as a production environment here. So you have to be careful in terms of typing in those words. So type in, click the reset. It's going to destroy all the the EC2 instances all the cloud resources that were created as if nothing happened, except the snapshot that were copied in the backend. You can also reset the DNS as well. Again, type in the reset, and Route 53 will be automatically reverted back to the East Coast as well. So all of that will be like, with few clicks, you're done with any of these changes. So the application will be down, of course, and now you can restart your production environment as if nothing happened. Your application comes back. All right, let me stop here and see if there are questions from the audience. Any questions? You could type in, you could, there is a question here. Key pairs. Yes, the key pairs will be automatically copied as well. So you don't, what happens is the key pairs is that we will orchestrate your KMS account. So again, we don't touch any of your keys, right? We are only managing them. So with appropriate permission, we will simply map the keys over to the other region. So that is very important question. Great question, by the way. And one of our customers is actually having 2 different key pairs. So that will be taken care of as well. Any other questions? Great. If there are no more questions, we will give you back additional 10 minutes of your time. And we are available over the email or any, if you have any doubts with respect to, well-architected framework and so on, with respect to just resiliency. We don't take care of other things. With respect to resiliency, we are here to help you out. Feel free to contact us. Thank you very much for your time. Have a great day.